The purpose of this lab is to investigate possibilities in separating a mixture into its constituent pure substances. We show that we are able to decant the mixture separating the solid from a liquid, then crystallize one of the components to separate it from the mixture. We are then able to filter the final component through vacuum filtration. We prove that we are able to separate a mixture into three pure substances by obtaining each individual substance and recording a mass for each. This is useful because it gives us the ability to find the composition of an unknown mixture.
To separate the mixture, we started by dissolving it in water. This would allow us to separate the sand from the salt and benzoic acid. The sand was decanted and put in a dryer to evaporate the water. The solution was then placed in an ice bath to try to recrystallize the benzoic acid, which would then be filtered out using vacuum filtration. The resulting filter paper would also be put in a dryer to evaporate the water. The salt water was then put on a hot plate to evaporate the water and dry the salt. Here are the results from our filtration. It is clear that there are discrepancies between our collected data and the accepted percent of each component. These discrepancies are most likely attributable to a faulty decantation and not allowing the benzoic acid to fully crystallize before filtering it out.
This is a graph showing the solubility of benzoic acid in water as it relates to temperature. In our graph, it would be reasonable to estimate that 0.4 grams of benzoic acid are able to dissolve in 100 grams of water at 25 degrees Celsius.
Because 1 liter of water weighs 1 kilogram, which is equal to 1,000 grams, we could expect that 80 grams of benzoic acid would dissolve in 1 liter of water at 42 degrees Celsius, as this is 10 times the amount that can dissolve in 100 grams of water at 42 degrees Celsius. The resulting solution would be unsaturated, and you would thus be able to see the bottom of the container. If you had an 11.65 gram sample of a mixture containing 3.64 grams of sodium chloride, 1.56 grams of benzoic acid, and 5.92 grams of silicon dioxide, you would have 31.24% of NaCl overall. If a lab team did not sufficiently recool the benzoic acid and letting it recrystallize, some of the benzoic acid would be filtered out during the vacuum filtration. If you added too much water while completely dissolving the benzoic acid, you would decrease the amount that would be recrystallized, leading to less benzoic acid recovered. In conclusion, we were able to separate the mixture into its constituent parts through separation, decantation, recrystallization, and vacuum filtration. However, the data points were not aligned with the accepted values due to the incomplete recrystallization and incomplete vacuum filtration.